Hello guys, can you hear me? Let me... Okay, I can see myself.
You hate meetings. Your team hates.
So, how was the contest today, guys? Did you enjoy the contest or not? B was cancer, weird. Oh, I see. It's very hard, not at all. I see that you guys didn't like the contest much. I got really close in a bunch of questions. For second, Q was just the sum of all maximum. We will talk about that. For K equals 1 either of the corners plus biggest. Yeah, we will talk about this. We will talk about the second problem. Let me just... I think we should wait a little bit more for the rest of the people to join as well. Today I have to leave around at 2 p.m. It's around 80-90 minutes from now, so I had to start sooner and we have to talk about the problems. We start talking about the problems sooner as well. It's been relatively a long time though, since the last time that we have had a stream and I've met you. We'll talk about it. Also guys, in the Telegram channel, I have put the vote for the next topic stream. Let me show it to you. There's a very close competition between segment tree and recursion and backtrack. I had to vote myself too in order to see the results, so I also voted for the things that I thought might be better. Right now recursion and backtrack is 113, segment tree is 111. They are very close. So today I will close these polls and decide that which one of these, I mean you will decide that which one of these you want to do. Why it became 106? It seems like many people. Okay, sorry, that was still more DP. 111, 113. It's a very close competition, and then we will probably we will have the stream on Wednesday. Let me see if there's a contest. Then no, there's no contest. Problem C felt under which topic? We will talk about it. This contest was absolute crap. Anyone from IIT Madras? Sham brother, are you Muslim? Why? Why? Well, first you guys say, what are you guys? Well, it depends on how you define it. What's your LinkedIn profile? Just search my name. Just search Shayan Chashp Jahan. Shayan Chashp Jahan. The first thing is my LinkedIn. I am Muslim, bro. Yes. I have to start ASAP as well. Let me also send the link to the Telegram. We can find the link to the Telegram channel here as well. Let me send it again here. Oh. So if you wanted to participate in the votes to decide the next topic stream, you can come here and then decide. So please decide on something, on one of these things. I'm okay with all of them. So whatever you choose. Right now, this has become 115. Segment 3 is 112. There's only 3 votes difference between them. Salam, Ilya. I got Sharon is here when we need it. Thank you. I hope that I can help. Salam. Can you do a bit masking stream, please? I've done it. I think I've done a bit masking W stream. And I think that now more people have joined us, so maybe we're ready to start as well. Anyway, in order to see the previous W streams, I should change its name to almost never on Fridays W stream. Because almost never it's on Friday. For example, even this week is on Wednesday. But anyway, I had Bitmask. I had DP Bitmask before. You can see it here. It was 3 months ago. The most popular one still by far is the first dynamic programming, then number theory, then graph theory. Any book for number theory, we can talk about it either. Can you say Salam Matin? Salam Matin. Was 3 possible? Guys, I wanted to ask something from you as well till more people are joining and we can get ready to start. What is your situation, guys? How many of you are from school? How many of you are from university? How many of you just want to participate in school competitions, high school competitions, for example, or anything else like IOI or anything else? How many of you want to participate in ICPC? How many of you are looking for a job and that's why you're learning algorithms and data structures? What is your objective? You want to find a job? You want to, for example, nail the interviews, or you want to participate in ICPC, IOI, what? Help me get a job, school IOI, school target IOI, job, uni ICPC, uni, also want to reach expert for some reason. Watch the video about how to get to experts, definitely. I guess that you have already watched it. I mean, I guess that almost all of you guys have already watched it, but anyway, in case anyone hasn't watched this, let me send the link here as well. Yeah, I can do a poll as well about it. Job and ICPC, high package, Olympiad, oh, Unipros, I want to brag my rating. Job, passing time, job. I see. So you guys have different goals. After giving 40 contests, I cannot break into pupil, never gonna make it to expert. You can. I just talked about how to get to expert. Well, Omnic says something that everyone can become a grandmaster. But even if you don't agree with that, definitely everyone can become experts. That's for sure. I mean, anyone can become an expert. As I told you, Omnic even says that, you can see in the interview with Omnic, he says that everyone even can become a grandmaster. But even if you don't agree with that, definitely everyone can become experts. You just need to, maybe you're not working in the correct way, maybe you're not working enough, maybe you're not working in the correct way. Any of this can be reason. I guess that anyone who wanted to join have joined by now. So are you guys ready to start? I just want to become a good programmer. Nice. Great. Shall we start discussing the problems? I also had a haircut recently. Not very recently, it's been maybe 5 or 6 days ago. But I think I really needed that. My hair was getting too long. Yeah, we really have a great community. If you want, you can join the Telegram group as well. I mean, there's a group linked to the Telegram channel. There's also a group. I send the link of the group again in the channel. And yeah, we really have a great community. Right now, how many people are in the group? 889. Around 900 people. we're close to get to 1000. And around 4,500 people are in the channel. I think everyone who is in the channel is good to also join the group as well, so that have access to this community as well. When are you going to release your course on competitive programming? Hopefully soon. Hopefully soon. And the point is that, yeah, if I have to focus on it for some time. I mean, recently I've been very busy, unfortunately, but I will definitely focus on it and make it ready very soon. And which platform do you like the most? Udemy, or just some website by myself, or somewhere else? Tell me about that as well. Yeah, sure. Let's start now. Now we are more than 150 people, so I think now we're ready to start. Okay. So let's start with problem A. Problem A to 0. It says that you are given two integers, n and k. K is an odd number, not less than 3. Your task is to turn n into 0. To do this, you can perform the following operation any number of times. Choose a number x from 1 to k and subtract it from n. However, if the current value of n is even, then x also must be even, and if the current value of n is odd, then x also must be odd. In different operations, you can choose the same value of x, but you don't have to. So there are no limitations on using the same value. Calculate the minimum number of operations required to turn n into 0. Okay. So if you take a look at it, it says that n and x. Bro, you had a haircut? Yes. I just talked about it. I recently, 5 or 6 days ago, I had a haircut. So yes, n and x, they have the same parity. So if n is even, x must also be even. If x is odd, n is odd, x must be odd as well. So what we can deduct here is that n minus x is always gonna be even. So each time, if your number is odd, you will subtract an even, and if your n is odd, you will subtract an odd number from it. So it becomes even. And also it's even, if it's even, you will subtract an even number from it, so it remains even. So always, after the first operation, always your number is gonna be even. Always it's gonna be even. Because at the first operation, you will make it even, and then it will remain even forever. Because after the first operation, you will always keep subtracting even from it, so it remains even. Maybe in the first step, maybe when you start, your n is odd, but that's the only time that it's odd. After that, it always is gonna be even. That's what we are sure. So there's gonna be two cases. The first case is that n is initially even. If n is initially even, we can forget about any odd number. Your number n always gonna remain even, and you will always keep subtracting an even number from it. And in this problem, also they have said that k is odd. They have said that k is odd. So you have to subtract an even number. What is the greatest even number that you can keep subtracting it? What is the greatest even number that you can subtract? Your n is even. Each time you can subtract an even number from it. Exactly, you can each time subtract k minus 1 from it. That's the most you can take. So what the idea is, we will subtract as much as we can. Because your number is always even, your conditions never change, nothing ever changes. You will subtract as k minus 1 as much as you can, and maybe at the end there will be something left, and that number that is going to be left is also going to be even. Then you will just subtract whatever is left at the end. So what your answer is going to be that way. So if your n is initially even, and your n is initially even, what is gonna be your answer at the end? Not understood. I will repeat it. Sure. Do you work out? Are you asking me or people there? And why? Exactly. It's sale of n over k minus 1. Exactly. It's the sale of n over k minus, sailing of n over k minus 1. So let me repeat it once again. All I'm saying is that if n is initially even, I'm saying that it always remains even. Always remains even. Why it remains even? Because it's even right now. The next time you will subtract an even number from it. So it remains even again. It's an even number minus an even number. The result is even. Again, you have an even number. As the result, you will again subtract an even number from it. It remains even again. I'm again wrestling with my microphone. Sorry for that. So each time you will subtract an even number from it and it will remain even. So the parity will not change. Another point is that your k is odd. The maximum number that you can take out is k minus 1. So the vice, and you know that the conditions never change. The number always remains even, and the numbers that you can subtract always are even too. So basically, what you can say is that, okay, keep subtracting k minus 1 from it. You know that regardless of what you subtract, your number remains even and the conditions are going to be the same. So subtract the most you can. This way, each time you will subtract k minus 1 until your number becomes 0. I mean, at the end, when your number is less than k minus 1, subtract a smaller number, whatever is remain. If you do this, the number of times that you have to subtract is going to be the sailing of n over k minus 1. Do you guys agree with this? So if n is even, your answer is simply the sailing of n over k minus 1. Sale of n over k minus 1. If you agree with it, please put a plus or use this 100 emoji. This is the case when n is initially even. I have to solve the case when n is initially odd as well. But for now, I'm just talking about the case where n is initially even. Okay, nice. If anyone also didn't understand, let me know. Didn't understand, let me know. All I understood is even and will always be even. Even if it is even. Yes, that's basically that. So the point is that your number always remains even and you have to make it 0 as soon as possible. So take out as much as you can. Subtract from it the maximum number that you can. Okay, subtract the maximum number you can from it each time so that you can get it to 0 as soon as possible. So this way your answer is going to be sale of n over k minus 1. Great. So now assume that your number is odd initially. So now assume that your number n is initially odd. You know that as your number, it's better if your number will be as small as possible. Still, when n is initially odd, you know that after just one operation it will become an even number. And after that operation, whatever that new number is, your answer is gonna be that new number, sailing of that new number over k minus 1. So in the first step, only in the first step, you should subtract an odd number from it, only in the first step. You should subtract an odd number from it, and then it is an even number, and you will again keep subtracting even numbers from it. So after one operation, if in the first operation you subtract x from it, if in the first operation you subtract x from it, your number becomes n minus x. N was odd and x is odd as well. So the number of operations that you're gonna need, because n minus x is an even number, the number of additional operations that you need to do is gonna be n minus x over k minus 1 again, because n minus x is now even. Again, you can use this formula. That was n over k minus 1. I mean, you know that when your number is even, the minimum number of operations to make it 0 is n over k minus 1. This way, the number of operations, the additional number of operations that you need is going to be n minus x over k minus 1. And there was one additional operation that we subtracted x from it. So now, which x is the optimal x to choose in the first operation? You know that in the first time you will subtract it by some x which is odd, and then your number becomes n minus x, and the number of additional operations that you're gonna need, because now your number is even, is gonna be n minus x over k minus 1. So how many, so what is the best choice for x? Exactly, the best choice for x is k, because this makes n the minimum number possible. If n was less than k, you will subtract n from it and you're done. So if n is less than k, the answer is 1. Only with one operation you can make it 0. Otherwise, you will subtract k from it in the first operation, and then you're gonna have an even number. And you know that the formula for even number is gonna be n minus k over k minus 1. And you add just 1 because of that first operation that you subtracted k. So if your n is odd, your answer is going to be n minus k over k minus 1 plus 1. So this is how you can calculate. And the scaling is also easy to calculate. I mean, just because this is problem A, and you might ask that how to calculate the scaling of n minus k over k minus 1. I do not recommend using C++ functions. Basically, scaling of a over b, always use it like this. Scaling of a over b is always equal to the floor of a plus b minus 1 over b. Always use this formula. So if whenever you wanted to calculate scaling of a over b, you can say that it's a plus b minus 1 over b. You add denominator minus 1 to the numerator and then subtract it, divide it by the denominator. So always keep this rule in mind. Whenever you wanted to calculate, let me change the color. Whenever you wanted to calculate scaling of something, just add denominator minus 1 to the numerator and then divide it by the denominator. Is it clear completely? If it's clear, please put the plus again or use this emoji. K cannot be 1. Yeah. So, and n cannot be 1 as well, so it's okay. I made complicated on me. I calculated how many operations I need to make n equal to... Oh, yes. That was not needed. You cannot be serious. About what? What is it? What is happening? That was where it was failing for k equal to 1. That means I used scale of x minus 1 over k minus 1. Well, maybe that can be shown that it's the same value. Do you guys need to show the code as well or not? Probably we don't get to F today because, as I said, I have to leave in around an hour. So I just wanted to very quickly say the solutions of the first problems, because I saw that nobody is streaming this contest, and I thought that maybe you need me to at least stream it, at least the first problems. If someone else was streaming the contest, I wouldn't stream this contest. But since no one else was streaming, I decided to stream and talk about the first problems. Okay, so no code. So just let's move on to problem B. Okay. So let's move on to problem B. Problem B, I'm waiting for it to be loaded. CF has become so slow. It's not loading. By the way, do you want me to change the color of my background until B is loading? Which color do you guys prefer? Choose one. Pink, it was pink. Pink is low. A certain problem with the screen was very bad. Yellow, pink. It's interesting that all of you are boys and still all of you prefer pink to all the colors, all the other colors. My eyes. Okay, so keep it as pink. Yeah. Pink suits the color of my t-shirts right now. This is the t-shirts that we had in World Final this year in Astana. The bad t-shirts. I mean, it was really bad. We messed up in ICPC World Final this year, so I don't like this t-shirt. Okay, shall we move on to the next problem? Okay, it's loaded, finally loaded. So, array recurring. You are given an integer array A of size n. Initially, all elements of the array are colored red. You have to choose exactly k elements of the array and paint them blue. Then while there is at least one red element, you have to select any red element with a blue neighbor and make it blue. The cost of painting the array is defined as the sum of the first k chosen elements and the last painted elements. You want to maximize the cost. So the cost is gonna be the sum of the first k elements plus that last element that will be colored. And you want to maximize it. Well, I read the problem just before attending the stream, and I have a solution that I think this must work. But you tell me if anything doesn't make sense. But I think it should just work as simple as this is. So let me tell you about it. So I'm saying that first assume that k is at least 2. K is from 1 to n minus 1. Assume that k is at least 2. I say that if k is at least 2, I believe that you can always choose the k plus 1 greatest numbers. I mean, you can always have the sum of k plus 1 greatest numbers. Do you guys agree with this? Has anyone solved it this way? Do you guys agree with this or not? Especially if you have solved it. I believe that if k is greater than or equal to 2k plus 1 greatest numbers is always achievable. Yeah, so you have used the same way as well. Okay, but I will explain why. I will explain why I believe so. Guys, assume that k is greater than or equal to 2. Now consider k plus 1 greatest number. K plus 1 is going to be at least 3, right? K plus 1 is going to be at least 3. I'm saying that choose a middle one of them. I mean, because k is greater than 2, there will be some elements out of this k plus 1 elements. K plus 1 can be anything, not necessarily exactly 3. But k plus 1, because it's greater than or equal to 3, choose one of them. For example, choose the second one. I want to make sure that both to the left of it and to the right of it, there are some other elements. Now choose the rest of these as at the beginning as the first k ones. And then you can simply go like this each time. First, make these ones blue and then come till here and make these ones blue and then make all these ones blue. And then come till here and make this one blue, and at the end make this one, this last one blue. This way you will count this one too, this last one too. So basically I'm saying that if k plus 1 is greater than or equal to 3, or in other words, k is greater than or equal to 2, you can consider the second one and leave it alone and choose the other k ones and make them blue at the beginning. And then you can just keep making others blue and just leave this one to be made blue at the end as the last one. And this way you can make sure that you have the k plus 1 greatest numbers. Do you guys agree with this? If you agree with it, please put a plus or use this emoji. K equal to 1. Yeah, I will talk about k equal to 1 separately. But why? Yeah, I just talked about why. Yeah, okay, sure. I will explain again. Let me see that how many of you have understood. Okay, I will repeat it. Let me also give you an example. For example, assume that these are your numbers. For example, this is like 10, 12, 13, and 11. And in between them, there are some small numbers. There's, for example, 1 here, 2 here, 3, 4, 5, 3, and 2, and 3. For example, assume that these are the numbers that we have, and assume that k is equal to 3. K is equal to 3 here. So k plus 1 is equal to 4. I want to show that I can take the k plus 1 greatest numbers. What are the k plus 1 greatest numbers? The k plus 1 greatest numbers are these. This 10 and this 12 and this 13 and this 11. I want to show that I can have the sum of this. How? I say that first let's make these ones blue. Let's make these ones blue first. I show it with arrows. The ones that I leave 12 alone. I leave the second one alone and I make the rest of them blue at the beginning. So basically this one is not blue, this one is blue, and this one is blue. And then I will make the others blue in a way that this second one that I left alone, I put it aside. This second one will be the last one that will be turned into blue. How do I do that? I say that, okay, first now let's make this one blue, and then make this one blue, and then make this 2 blue. I will keep moving, but I don't make this 12 blue. And then I will make this 4 blue, this 3 blue. All of them, you see that they had a neighbor, so I'm going one by one. Then this 5 blue, then this 3 blue. Then, because this 11 is blue, I can make this 2 blue, and then this 3 blue. The point is that I can keep this second chosen one as the last one that will get blue. So this way, this is gonna be the last one that I'm turning it into blue. So this one will be also summed up. So the point is, if you consider this second one, I have chose elements before it and after it. Using this, I can make all of the things in here blue. And using this, I can make everything in here blue too. And this one will be the last one that will be turned into blue. So this one will also be considered as well. So anyway, I'm saying that I can have the sum of the k plus 1 greatest blue ones. The greatest elements that which are gonna get blue. Greatest elements, to be more precise. Is it clear now or not? Are you attempting contests from any alternate accounts? No, I don't have any alternate accounts. I'm not attempting contests. I don't have time, unfortunately, anymore. How do you get a job if I'm not? If you want, guys, I can make also a separate channel for only the people who are looking for jobs, so that you guys can make connections as well there. For example, if one of you have done an interview somewhere, they can let others know, and you can connect. You can have connections with each other. If you want, if that helps you, I can make a group for that in Telegram as well. No signature channels. Okay. So if you understood the solution, please use this 100 emoji or put a plus. Yes, I will also explain k equal to 1 as well. Yeah, please make sure. We will talk about it. If you want, I will make it. Can you please suggest a good code for program student? Yeah, we will talk about that. I will talk about k equal to 1 as well. For now, I'm just asking about k greater than or equal to 2. Yeah, please never discuss about jobs in this channel. Only discuss CP. Yeah, that's the plan. Maybe I will become a pupil today. Thanks. Great. Let me know if you made it. I recently have heard in LinkedIn so many people have mentioned me in posts that they have become something, for example, experts, specialists, something, and it's really interesting. I always get excited, and I also put a comment there because it gives me a notification when someone mentions me in their post and they tell me that they write a post that they have become, for example, something. I get a notification in my phone and I get very excited. I believe you're something because you're handsome. Who are you talking to? Maybe I will become newbie today from pupil. Codeforces Educational tutorial. No, I haven't explained C. I want to now discuss about the case where k is equal to 1. Now assume that k is equal to 1. So if it's completely clear that when k is greater than or equal to 2, what happens? Now let's talk about k equal to 1. Because the point is that when k is equal to 1, you can be sure that the last elements that will be turned into blue is either the leftmost one or the rightmost one. Because assume otherwise. When k is equal to 1, you always have a consecutive set of elements which are blue. When k is equal to 1, you always have a consecutive ones. You start from somewhere and will go rightward and leftward. You will always have a consecutive set of elements which are blue. And each time you can extend it from right or left. Therefore, it's not possible that something other than the leftmost one or the rightmost one will be the last one. You can easily show that with contradiction. Assume that the last one, for example, is this one. And everything to the left of it has become blue. Everything to the right of it has become blue as well. This is a contradiction because we just said that always a continuous part is blue. When k is equal to 1, you start from some point and extend it from two sides. So it's always an interval of blue elements. It's not possible that the last one that turns blue is something in the middle, because it means that everything in here has become blue and everything in here has become blue as well. But this one is not blue yet, and this is the last one that we make it blue. That's not possible. So you have to keep in mind that when k is equal to 1, again you are gonna have k plus 1 elements, but one of them for sure must be one of these two ones. The leftmost one and the rightmost one. So now consider the maximum. Either maximum is from one of these two sides. If that was the case, we're happy. Because if the maximum is either the leftmost one or the rightmost one, we're happy in that case. Because it means that, okay, that condition is satisfied. That the last one will be from one of these two sides. And then the answer still is going to be the sum of two maximums. Because if one of them, for example, assume that one of the maximums is this one, and the other one is going to be anything in here. You can start from this one, make everything blue till here, until here, and then this will be the last one that will be turned blue. So if the maximum is one of these two last ones, you're done. The answer is going to be the sum of two maximums. Otherwise, your answer, if maximum is in the middle, your answer is going to be maximum, that maximum plus the maximum of these two extreme points, the leftmost one and the rightmost one. So in that, so you should have also the maximum of the leftmost one and the rightmost one, and add that too. So this is how this problem will be solved. If k is equal to 1, definitely one of these two extreme points must be chosen. If the maximum was one of these two endpoints, we're happy because that condition is satisfied. We're happy, we're good. So the answer is going to be the sum of these two maximums. Otherwise, if that was not the case, we can say that the answer is going to be the maximum plus the maximum of these two extreme points. So this way k equal to 1 can be easily solved as well. Is it clear? If it's clear, please again put either a plus or this emoji. If it's not, put a minus or ask me questions, anything that is not clear. Solve the same way, great. If you want, I can show you the code as well. And if you want, we can skip to problem C. Awesome. Please one dry run, code, go to C after looking at. Okay, so to do something that all of you makes all of you happy, I quickly show the code so that it makes everything clear for you guys. Let me show maybe this code. Let me see input and ans. Let me see how has he done it. So if you take a look at it, he has also done the same thing. It says that if k was not equal to 1, sort everything and then reverse it, sum up the first k plus 1 elements from 0 to k itself. It's going to be k plus 1 elements. So just sum them up and return that. Otherwise, your answer is going to be, he's done an interesting thing. He puts the answer as the sum of these two extreme points, and then what he does is he has a 4 on all the middle elements, and he says that res is equal to maximum of res and ai plus maximum of these two. So basically he first considered the case that we take these two, we don't use middle ones, so it's going to be the sum of these two extreme points, and then he considers the case where a middle point will also be chosen. So he will have a 4 on I, and he says that, okay, I choose AI as one of them, and the other one will be maximum of these two. This was also an interesting way to do it. So this is the case that no middle one will be used. If a middle one will be used, he has a 4 on, okay, which middle one is going to be used. And it's going to be AI plus maximum of A0 and AN minus 1. It was a very beautiful code. Let me share its link to you as well. Okay, is everything clear now? If it's clear, we will move on to problem C now. Maybe we can just take greatest elements, and then for k equal to 1, take max endpoints and remaining max elements. Yeah, that's also true. We can take max endpoints and then add the maximum remaining elements. Okay, let's go to problem C. 2 colors. It says that Monocarp has installed a new fence at his summer house. This fence consists of n planks of the same size arranged in a row. So basically what it says is that we have a fence and we have these rules. Each plank of the fence will be painted in exactly one color, and the number of different colors that the plank will be painted in is exactly 2. So we have a fence, we want to color the planks such that the number of colors that we use is exactly 2. And the planks are gonna form a continuous sequence. So a prefix is gonna be the same color, the first color, and the suffix is gonna be the second color. So monocarp has M different paints, and the paint of the I color is sufficient to paint no more than A sub I planks of the fence. Monocarp will not buy any additional paints. Your task is to determine the number of different ways to paint the fence that satisfies all of monocarp's described wishes. Two ways to paint are considered different if there exists a plank that is painted in different colors in these two ways. So basically, we have different colors. Each color, we have some supply of each color. For example, here, the first color only can color 2 planks. The second color can only color 4 planks. And we want to color the fence using only two colors, and a prefix must be one color and the suffix must be the other color. And we have to see that how many ways do we have to paint it. 2 ways are different if the color of one plank is different in these 2 ways. Let's first solve the problem when k is exactly 2. Let's first solve the problem if k is exactly 2. So we know that which colors we're gonna use. And AIs are also up to n. Definitely. Otherwise, we could make them mean equal to n. If they were greater than n, we could set them to be equal to n. Now, if we have 2 colors, and the first one is, for example, A1, the second one is A2. We have A2 of that. How many ways do we have, guys? If we have 2 colors, the first one, we have A1 of the first one, A2 of the second one. How many ways do we have then? Let's first solve this easy k equal to 2 case. Yes, that's right. That's a good point. Let me mention this point to everyone as well. That's a point that also helps us a lot. We can also say that AI can be mean equal to n-1 as well. We can also consider that. We can also assume that AIs are at most n-1. Because we will not use more than n-1 supply of a color. So if AI, you can at the beginning say that if AI was greater than n-1, just make AI equal to minimum of AI and n-1. This is a pseudocode, guys. So if AI was, let's set it equal to, n-1, because it's greater than n-1 already. Or we could just say that AI is equal to minimum of n-1 and AI, instead of having this if. Basically, I'm saying that we will not use more than n-1 supply of the same color. So you can also assume that AIs are up to n-1. Even though in the inputs they're up to n, but you can simplify it a bit further and make them be at most n-1 instead of being at most n. Do you guys agree with it so far? And then we will talk about what we have here. Okay, nice. So now we have A1 and A2, both of them are at most n-1. So how many ways do we have now? Let me send you the link of the third question. It's basically, you can read it as well if it wasn't clear. But in order to summarize it once again, we have a fence, it has n planks, and we have k colors, we have m colors, color number m, we have AI supply of that. I mean, we can paint AI of, at most AI of planks using that color. We want to use exactly 2 colors such that each color will be a continuous subsegment. So the first one will be a prefix, the second one will be a suffix. You have to say that how many ways do we have to paint this fence using exactly 2 colors. Okay. So guys, once again, I'm asking that if we have A1 and A2, What is the formula? How many ways do we have? We are solving the problem for the case where k is equal to 2 exactly. We're solving for the case where k is equal to 2. How many ways do we have? A1 plus A2 plus 1 minus n 2 times A1 plus A2 minus n plus 1. Great. Exactly. Exactly. The number of ways you can see that. So basically first we are solving an easy subtask. So this is a way that can be used in many problems. Guys, so many of times you can define an easier subtask and try to solve that one first. That gives you some hints on how the main problem will be solved. This is a very important technique that you need to learn. That when you're facing some problem, first try to define some subtask, some easier version. See that, okay, if it was this specific part, how could I solve this? Okay, so that's exactly this. 2 times A1 plus A2 minus n plus 1, as many of you have said. Why is it equal to that? Because first, we have two ways. Either we want to use the first color first or the second color first. So because we know that a prefix will be from color 1 and the suffix from color 2, or we can completely flip it. A suffix will be color 1 and prefix will be color 2. So we have 2 times. Now we have to see that how many of them will be color 1, how many of them will be of color 2. That's also something that we should consider. So the point is, if A1 plus A2 is exactly equal to n, we have exactly one way for that. We should have exactly A1 of color 1 and A2 of color 2. But as long as A1 plus A2 was equal to n plus 1, then you can easily see that we had two ways. Why? Because we could either use A1 of the first color and A2 minus 1 of the second color, or A1 minus 1 of first color and A2 of second color. So we would have two ways. If A1 plus A2 was n plus 2, we had three ways. Why? Because we could either have A1 minus 2 of the first color, A2 of the second color, A1 minus 1 of first color, A2 minus 1 of second color, or A1 minus A1 and A2 minus 2 of second color. So basically just arrange A1 of the first color here, A2 of second color here, and because we know that both of them are at most n minus 1, now we can just choose any segments. I mean, we can just look at our planks, our fence as a window of this. I mean, it's like we choose a window that, okay, we will color it like this. If the window is like this, it means that we have these many of the first color, these many of the second color. If I move the window to here, I will have these many of the first color and these many of the second color. So the point is that just as long as I have A1 of the first color here, A2 of the second color here, and just I then choose my window when I want to put my n fences. And how many ways do I have to choose that where do I want to put my fence? I fixed that, for example, I just multiplied by 2, and then now I'm considering that first I have the first color, then the second color. So I put A1 numbers of the first color here, A2 of the second color here, and then I will choose a window of it. And wherever this window lies, it will fix for me that what is going to be the number of the first color and the number of the second color used. So basically this way, the number of ways that I will have is going to be A1 plus A2. The length is n minus n plus 1, because this I can fix the starting point of my fence. The starting point of my fence can be here or here or here or here or here. So the number of ways for the starting point is going to be a1 plus a2 minus n plus 1. For example, if a1 plus a2 is n plus 2, I could start from index 0 or index 1 or index 2. So it's going to be 3 ways. Is it clear? So far I showed that I only solved the problem for a case where k is exactly equal to 2. I showed that if k is exactly equal to 2, the number of ways is going to be exactly a1 plus a2 minus n plus 1, the whole thing times 2. If it's clear, please put a plus or use this emoji. If it's not, put a minus or ask me that which part, tell me which part was not clear. a1 plus a2 less than n. If a1 plus a2, that was a good question. If a1 plus a2 was less than n, the answer is 0. That was a good question. If a1, only in this specific case where a1 plus a2 was less than n, the answer is not negative, it's 0. So we'll max equal it with 0. Okay, sure. I will suggest a good CF ladder. Maybe I put it in the Telegram channel. So anyway, okay, good. Only in the case where that was a very good thing that you mentioned. If a1 plus a2 was less than n, the answer is 0. So now let's solve the problem in the general case. Now k, or instead of k, let's say it was actually m, but I used k. So I hope that it doesn't confuse you. Now assume that k is greater than 2, or m as in the original statements. Assume that k is greater than 2. Now I should also fix that which 2 colors I want to use. So one solution that comes to my mind is of k squared to first fix and then sum up these values. But this is gonna get time limits. Let me change it to m so that to make sure that you won't get confused. Assume that m is greater than 2. One solution is of m squared that we have. Fix which 2 colors you're going to use and then add up these values. But this is going to be problematic. Why? Because m is up to 2 times 10 to the 5th. So this is going to be slow. We have to optimize it somehow. This is going to be slow. We want to optimize it. Let's now, in order to optimize it, let's fix the first color that we're going to choose. I mean, let's fix the color of the prefix. Okay, let's just fix the color. So I have a 4 on I. I said that, okay, I is going to be the first color that I want to use. I have to see that first, which other J's are able to paint the fence with I. Definitely, I should only consider the J's where AI plus AJ is at least n. Okay, if we have some J such that AI plus AJ is less than n, they cannot paint the fence together. So let's say that we have sorted all the AIs. I can easily do a binary search to find out the first index J such that AJ, A sub J is greater than or equal to n minus A sub I. So I know that anything before this, they cannot match with I. These cannot match with I. Because in total they're gonna have less, they can paint less than n planks. But for all the J's after this, I have to sum up AI plus AJ minus n plus 1. If I just have the sum of these values, if I have the sum of these AJs, let's call it S, and I have the number of them, let's show it with C. Assume that they are C numbers here and their sum is S. Then I can say that, okay, the sum of all these ages, when I want to calculate this sigma of AI plus AJ minus n plus 1, The sum of ages, I can put out the sum. This sigma is going to be the sigma of aj's plus sigma of ai. Sigma of ai is, because we know that we have c elements here, it's going to be c times ai. And we have a minus n, which will be calculated c times again, minus cn. And we have a 1 here, which again will be calculated c times, so plus c. And sigma of aj is also equal to s. So basically what we have in here is going to be s plus c times ai minus n plus 1. So we just need to have what is the sum of these values, what is the sum of these values, and how many numbers are here. So with a binary search and prefix sum or suffix sum, we can just see that what are the sum of these values. We can have a suffix sum. Okay, we say that from the ends to here, what is the sum of all ages. Then we do a binary search and we sum these values up and add the number of them, the c times ai minus n plus 1. This way we can add all of them together instead of having a 4 on them one by one. Only there's one special case that ai will be here as well. So you have fixed ai for the first color, and ai is your second. You have chosen ai for your second color too. ai is your first color, but you have also chose it for the second color too. You can just see that if ai was to the right of this, or you can just have an additional if. You say that if ai plus ai was greater than or equal to n, in this case you will subtract this case manually. Only this special case will be subtracted as minus equal to ai plus ai minus n plus 1. Because you have counted it too, but you will subtract it because it should not be counted. So yes, exactly. The solution will be suffix sum or prefix sum. I mean, that's the same as prefix sum. Plus binary search. That's all. That's all. Is this clear? If it is, again, please put a plus or use this emoji. Let me take a look at the votes again. 124, 118. So it seems like recursion and backtrack is winning for the next W string. Yes. Well, the case was that AI cannot be matched with AI itself. But in binary search and suffix sum, you are considering it once again. I mean you are considering it. AI cannot be matched. I will explain it from the beginning. So I said that if k is equal to 2, the answer, if I have a1 of the first color, a2 of the second color, the answer is going to be a1 plus a2 minus n plus 1. We said that the answer is going to be this. Because I said that it's like put a1 of the first color, a2 of the second color here, and then choose the window. Choose the window. Because each one of them are up to n minus 1, you can easily just choose the window. That when your fences are, and that window will fix that how many of the first color you will choose, how many of the second color will you choose. Now I'm saying that instead of having a 4 of m squared and fix those two and add up these values, let's just fix the first color that you're gonna use and then sum up all the possible j's that you can have in here. When I fix I, j cannot be in a way such that aj is less than n minus ai. So if a sub j is less than n minus a sub I, these two cannot color all the fences. All the fences. So I can do a binary search and find the first element that is greater than or equal to n minus ai. J cannot be before that. J must be after that. And now I say that I should calculate the sum of ai plus aj for all the j's in here, for j from some k to n. I used one base indexing. I should calculate this sum, ai plus aj minus n plus 1. This is equal to the suffix sum. I mean, if you calculate, you add with all the suffix sums, you have the sum from everywhere to the end. This is your suffix sum, this is s. So you add s, you have s here, plus. Then, if the number of elements that you have is c, it's gonna be, you're gonna have c times ai minus n plus 1. So your answer is gonna be s plus c times ai minus n plus 1. I lost my pen. I have to take it. Wait a second. Okay. So basically, I have to calculate this sum and this counter. I have to have these values. So I have this suffix sum and I have that how many numbers do we have. So this way it's gonna be s plus c times ai minus n plus 1. What was this? This last part, basically I'm saying that if ai plus ai was greater than or equal to n, I have calculated ai with itself once. Okay, I have calculated ai with itself, but ai cannot be calculated with itself because you cannot use the same color twice. So you have to subtract it manually. So for that specific case, you will subtract it from ans. Ans minus equal to ai plus ai minus n plus 1. Is this clear now? So here I am also. If it's clear, please put a plus or use this emoji. Can you explain it with an example? Okay, we'll go over an example as well. And guys, I guess that today we cannot discuss problems D. Because as I said, I have to leave too soon. I'm sorry for that. But I guess that we don't get to problem D today. So if you were waiting for problem D, I'm sorry for that. I hope that so far it has helped. And let me see that if tutorial is out. Tutorial is not out yet. Oh, E for sure we can get to E. Okay, so let's discuss a quick example. For example, in here, guys, we have 12, 3, 5, 9, 8. But in here, everything can be matched with each other. So let me, first, as I said, we will sort the numbers. We have 5, 8, and 9. Okay. Each one of them can be matched with anything. So for each two of them, we should have ai plus aj minus 1. So I start from this 5. I assume that this is my ai. I have to see that what is the first index that can be matched with it. Everything can be matched with it. So I start from here. For each one of them, I should add ai and aj minus n plus 1. This is what I should add. Well, the point is that ai minus n plus 1 part is a constant part for all of them, and aj is the sum of all the indices that we have. So basically, we have 3 elements in here, and their sum is 5 plus 8, 13 plus 9, 21. So what will I add? I will add 3 times 5 minus 12 plus 1 plus 21. What is 5 minus 12 plus 1? It's minus 6. So it's minus 18. Right? So it's gonna be 3. If I'm right. Yeah, it will be 3. And the point is that, oh, sorry, I made a mistake. 5 cannot be matched with itself by default. Sorry. 5 cannot be matched with itself, so I start from here. My binary search starts from here, from this 8. So we will have two numbers, and their sum is gonna be 17. So it's gonna be 2 times 5 minus 12 plus 1 plus 17. So it's gonna be 5. And then we do it for 8. For 8 we can start from the beginning. So it's gonna be 3 times 8 minus 12 plus 1 plus 21. This number is gonna be minus 3. So it's gonna be minus 9 plus 21, which is gonna be 12. Sorry, it's 22. It's 13. And the point is that here I see that I have fixed AI with itself. I have fixed 8 with itself. So manually I should subtract 8 plus 8 minus 12 plus 1. Manually I should subtract this 8 plus 8 minus 12 plus 1, which is gonna be 5. So 5 must be manually subtracted from this. So this will turn into 8. And then we do the same thing for 9. If we don't have any other errors, this should give us the final answer. So for 9, again I start from the beginning. It's gonna be 3 times 9 minus 12 plus 1 plus again 22. This is gonna be minus 2 minus 6, which is gonna be 16. 9 has been calculated with itself, so we should subtract it. It's gonna be 7. So this will turn into 9. So the answer is gonna be 9 plus 8 plus 5, which is 22. And it is 22. I hope that it's made this clear. I know that it got very messy because it has so many calculations. So I had to, I made some small errors. But anyway, at the end it gave us that 22 that we were looking for. Is it clear completely? What the age limits for ICPC? I think there's not much age limits right now because it's now so many. I guess that last time some person with age 27 participated, it was some age limits, but I think that for so many different reasons they skip it. I mean they give exemptions for so many different reasons. If it's clear, please put a plus or use this 100 emoji. And if it's not, let me know. By the way, I started my bachelor's at 26. I don't know, maybe you can participate. I think you should send an email to Bill, I guess, and Bill Poacher, and tell him that, for example, this is your situation and they want an exemption, and they probably give you an exemption if you get qualified, and then you can participate. As I know, someone participated in last ICBC and his age was 27, I guess. Okay, is everything clear? And for problem D, I don't know if we can quickly discuss something about it or not. Maybe I just show the code quickly, because how many of you guys are here for problem D? I don't want to leave you without anything. So if there are so many of you waiting for problem D, we can talk very quickly about it. I have to leave in 5 minutes, but it's okay. I try to do it ASAP. How many of you are waiting for D? Okay. Okay, sure. I will discuss problem D as well. Very quickly, I will show a code. Let me bring problem D. Okay, the statement, you should have known this statements, I guess, if you're waiting for problem D. So it's basically you have X and Y. I said very quickly because I assume that you know it. I send the link here as well if someone didn't know it and wants to read it. Basically, it says that we have X and Y. Each time we can divide one of them by 2 to the power of K, rounded down, and the cost of this operation is 2 to the power of K. You have to say what is the minimum cost to make X and Y the same. So X and Y are up to 10 to the power of 17. Let me quickly show a code. Let's see what has he done. It seems like a DP, f of 0 and 0, f of j and k is the minimum of f of j and k minus. Interesting. It's good that we have discussed it because it looks like a very, very beautiful problem. Wow. It really looks like a very beautiful problem. He has a 4 on I and then J. He wants to see that what is the minimum cost basically, first of all, if you consider it in binary representation, the first operation is to remove the operation is to remove several binary digits, several bits from the end of your number. So he wants to see that what is the minimum cost to remove J indices from the first one, K indices from the second one. And awesome. That was a very beautiful solution. I'm happy that we have discussed it. Let me explain it. Okay. So basically in this problem we have two integers, X and Y, and each time we can choose some K and divide one of these two numbers by 2 to the power of K, and the cost is going to be 2 to the power of K for doing this, and we can only use each K only once. You have to say that what is the minimum possible cost to make these two numbers equal. So we use dynamic programming on this problem, a very beautiful dynamic programming. I first forget about what X and Y are. I forget about the queries, what X and Y are, etc. I forget everything about that. I will only focus on my DP for now. I set some DP of I and J. DP of I and J is, well, let me first tell you this. Basically, what you are doing, dividing something by 2 to the power of K, means that if you look at it in binary representation, you are removing the last K digits. You are removing the last K digits. That's equivalent to this, removing the last K digits. So now I'm saying that assume that each time we are removing some digits from the end of one of these two binary numbers. DP of I and J is the minimum cost to remove I digits from the end of the first number, J digits from the end of the second number. DP of I and J is this. I want to see that what is the minimum cost for that. How do I do it? I have a 4 on all the possible bits that we have. We might use them, we might not use them. I have a for b, which is on the bit. X and y are up to 10 to the power of 17. So our bits are going to be from, for example, 0 to 60, for example. And the number of bits that we remove also, they're going to be, for example, up to 60 as well. Maybe we can consider some additional ones as well. For example, instead of 60, let's say 64, because maybe you will remove more. Maybe remove more to make these numbers 0. Maybe, for example, your length is, for example, 10, but you remove 12 to make both 0. So I consider a bit more, for example, like 64 or 63. 63 is still not good. Well, because for B, you can set B to be at most 60. You will never choose something more than 60 because anyway your number will become 0. But for I and J, you can consider that I and J are up to 70 or even up to 100. Okay, assume that we will definitely not remove more than 100 elements from both numbers. So first we have a for on all the bits is from 0 to 60, and then we have a for I from you want to update DP of I and J's, but you have to update everything only once. I mean, you cannot use this bit B more than once. So how do I make sure that I will use each number only once? How do I make sure of that? Well, I will have my fors in reverse order. If I have my fors in reverse order, instead of going from 0 to 100, I go from 100 to 0. I make sure that when this DP will be updated from something before it, that one is not updated yet. So that one hasn't used B yet. So I make sure that B will be used only once. From 100 to 0, or if your size is 199 to 0, and then you have a for J from 99 to 0, and you will update DP of I and J. DP of I and J will be updated from DP of, you can either use B on I or on J. So it will be updated from one of these two things. It would be minimum of itself, DP of I and J, and minimum of, either you use DP of I minus B and J, definitely if I is greater than or equal to B, or DP of I and J minus B plus 2 to the power of B. So this way you will update your DPs, and at the end, when you get the queries, in your queries you get X and Y, you will have a for on all the values possible for I and J. And then you will see that if you will have a for on all the values of I and J, and you will see that if they were giving you the same values, if X shifted by I will give you the same value with Y shifted by J, your answer will be mean equal to DP of I and J. If X shifted by I is equal to Y shifted by J. And that's all. And the point is that you don't need to have it for up to 100 as well. Even as you see in this code, up to 64 is going to be enough too. 100 might be a bit too much, because if you have it up to 100, your time would be 10 to the power of 5 times 100 times 100. Time limit is up to 3.5 seconds. If you have 64, you can do it. If 10 to the 5th times 64 times 64, 64 times 64 is 26. 2 to the power of 6 times 2 to the power of 6 is 4096, is around 4000, is 10 to the 5th times 4000. So it's going to be 4 times 10 to the 8th. So it's good. You can have your force up to 64, and you can check that if x shifted by I was equal to y shifted by j, you will minimize rest with f of I and j. It was very quick explanation of problem D. I hope that you understood it. It was a really beautiful problem. Oh, I see. Was it clear, guys? Did you understand the core idea? I just tried to quickly explain it with our time constraints. Okay, nice. Nice. I hope that you used this solution discussion. Soon we will have our topic stream. Do not forget to put your votes. I will close it in a few hours. Let me see that what is the result right now. Recursion and backtrack 124. Segment 3 119. Only 5 votes difference. It's crazy. I really don't know which one will be chosen. So whatever you prefer, you can say it here. Let me know if you have any preferences. Choose it in the votes, and then I will finish this poll today as well. See you guys very soon in the next topic stream, which is maybe on Wednesday. No, it was funny, sure. Okay, see you guys on Wednesday. Goodbye.